Good afternoon, everyone. Do you hear me? It's okay. I'm working in the IT department of the French Ministry of Interior. The Minister of the Interior is responsible for the following: the general interior security of the country, the French National Police, Gendarmerie, and granting the identity documents like passport or ID cards, and driving license, so on, logistic and organization for political elections. I'm part of a DevOps team in charge of developing a cloud offer for our internet customers. We offer an OpenStack cloud secured access, and we have a security accreditation to host sensitive applications. Our customers need to store data and applications that necessitate a private cloud. We can't go through our Amazon Cloud or Google Cloud platform. It's not possible. I'm here today to talk to you about Ceph deployment. I'm very happy to be with you because I love Switzerland. Firstly, I will give you some element of the context. What's inside our cloud, in our cloud offer, sorry. Our strategy to develop from dev to prod, how do we make it with CI/CD tools like that. Explain the need of scalable storage because our customers need some more storage than before. And in the second time, I will give you a few numbers: how many petabytes, size of clusters, our implementation model, what's going on with OpenStack, and our S3 service, new offer with replicated service. I will explain you how our storage is deployed, and I will give you some benchmark because I think you like it. Let's start with the cloud offer. Look at our API customers. They want to use OpenStack. How do they make it? They ask a user portal, a homemade user portal, to get a tenant with configured network, security groups, and so on. And they can access to their tenants via SSH and HTTPS, and also all the API, OpenStack APIs, to create their computing with its stack and so on. But they always say that it's not as fast as they would like to be because we have many firewalls to protect everything. It's the problem of the Interior Ministry. So a few key figures regarding our cloud. We have 80 terabytes of block storage on our cloud, 4,000 instances, 8,000 vCPUs, 21 terabytes of RAM, and many computes. And we are a small team to have two clouds to manage. It's a bit hard, but we're succeeding. Our dev to production strategy. We want a reliable deployment, so we're working with a CI/CD. We don't go to the server with SSH to install package. We have developed everything to make it run by itself. So we have many environments, like two-stage environments, two dev environment, two staging, and two production. So we can try to make some new deployments over our dev environment without disturbing the production. Our DevOps team is in charge of dev and delivery, and another team is in charge of pushing new releases and staging and prod platforms. Concretely, we release new services on the CI, and deployment is run by a CD. So our operating team just have to click on the button on Jenkins, and everything is deployed. So almost no human mistake can happen, but it happens. Focus on the storage. Today, we are using an old technology included with our OpenStack platform. We use Helium OpenStack. I don't know if you know it. You know that platform, but it's VSA. It's a storage platform. It's a proxy between a high-end base storage and cloud platform. So it's not very fast, and we have some difficulties to make it run well. And we are happy to go to Ceph because it's more reliable and big storage. We thought that configuration between our cloud and the legacy storage base was very complex. Extensions were very hard and long to deliver. It was expensive. And SAN is so 2010. So we needed to find a better storage system that would be scalable and easy to configure. Here is the production setup we are going to deploy. We have two clusters, one for block storage. It serves the RBD for OpenStack volumes, and one object storage cluster for S3 and Swift. So for blocks cluster, we only use SSD storage because it's faster. We made some tests, and for small IOs, it's really better. You have to know. And for object cluster, we use some NVMe card because it was used by wall and DB devices to be faster. Our implementation model. First, we had to develop Ansible and Walls playbooks to plug our cloud, Helium OpenStack, to an external storage because it was not. We had some headaches to integrate this external storage because HOS, Helium OpenStack's package, didn't allow it natively. We are going to offer S3 service with bidirectional replication, 2 endpoints, one by seat, and then the customers can access to the same data everywhere. If one seat crashes, they can go over the second one. After the reboot of the seat, every data are resynchronized. So and I'd like to say, it's the next step. In our storage deployment, each cluster is made of one deployer node. It's a VM, virtual machines, 3 monitor nodes, 2 Rados gateways for object clusters, and minimum of 4 OSD nodes. We tried really recently a Nautilus version. It adds some better support of decommissionment with OSDs. It's easier to use than Luminous, I think. And by the way, when we need to decommissionate an OSD, a dead OSD, you don't have to think, where is my wall, where is my DB, on which device is it? It's going to release everything, and it will be clean. A few words about our deployment, our automation. We use a cobbler server to deploy every node with an Ansible integration, and and after we use Ceph deployer. It's a VM too to get the node run with Ceph. Our deployment steps are following. Cobblers install everything on every physical node, and Ceph deployer configure every node with Ansible, configure /internal repositories, builds pulp, because we need also a repository with stage repositories. It's important because when you're deploying over many platforms, you need to have stage environments to do not get more recent updates on a compute on a node than another one. Update every servers with latest stage repositories. Install prerequisite package, update server configuration, and so on. And after, we use SUSE installation, because we need the support to get it run. And it is integrated with Salt and DeepC. So the discovery of the cluster and the configures is made by DeepC. And DeepC works with the last version of Ceph, so we can use the last Nautilus package. We did some benchmark with